All right, we are going to go over, we're going to do a lot today, okay? So today is the 31st, it's the last day of the month. As we wrote down yesterday, I am going to go through the warm-up with you, and I need you to watch the video. I need you to watch this video all the way through, okay? Your homework for tonight is going to be the Tuesday homework. I probably will not post this homework help until Wednesday, okay? All right, because I want you to try it first. Okay, so let's get it cracking. I want you to pause the video so that you can work on the warm-up alone. Pause the video at this time. Okay, so let's see what you have. Let's see what you got. All right, which number is an irrational number? Okay, here is a non-perfect root, so this is irrational. It's irrational because, again, it is a non-perfect root. This is a negative fraction. It makes it rational because it can be written as a fraction. And this is a perfect square root, which is equal to 25. This is also rational. All right, let's look at number 2. To solve this equation, we've got to get x by itself. So we want to get rid of the negative or minus 11 first. So we are going to add 11 to both sides. We add 11 to this side. This gives us 27. Okay, I'm going to bring down the x divided by 3. This is division. The opposite of division is to multiply by the reciprocal here. So we're going to multiply by 3, or 3 over 1 on both sides. When we multiply by 3, this is going to give us 81. So we have here, don't forget, get 27 times 3, and you'll see that it is 81. This cancels out, and that's going to give you x is equal to 81. All right, hope y'all got that right. Number 3, this is distributive property. So we're going to multiply 1/2 times both numbers in the parentheses. Half of 8p is 4p. Half of a negative 2w is negative 1w. Or another way to write that is just to say minus the w. Okay? Either one is your answer. Cannot combine those terms, so you're done there. Simplify. We're going to only combine terms that are alike. So here, you can only combine the ones that have the x attached to it along with the same exponent. So if these were different exponents, you still couldn't combine them together. So you can combine 5x to the third minus 1x to the third, and that's going to give you 4x to the third. Okay? These two you can combine because not only is it the same variable, but it has the same exponent attached to that variable. So you got 3y to the second plus 1y to the second. So that's going to give you a positive 4y to the second. Okay? And this is your answer. These are not like terms, so it's simplified. Which of these values is the greatest? This is already written as a decimal. Let's do this squared. So that means you multiply 3.21, and you're going to square it. The square button is right here. And that gives you 10.24. The square root, let's do the square root of 108. We know it's going to be between 10 and 11. Okay. Is it closer to 10 or is it closer to 11? It's closer to 10 than 11. And you can see it's 10.39 and some change, okay? And 10%, okay? So 10% is 0.10 times this 103.5. And that gives you 10.35. So which one is the largest? So the largest is going to be this first one, 10.4. Okay. All right, so now let's look at the table. We're going to do it the same way we did yesterday. And you're going to see this is your input, remember? This is your output. So if you plug in 1, your answer should be, or your output should be 1. If you plug in 2, your answer should be 3. If you plug in 6, your answer should be 11. So which one of these are going to give you that? So there are a few that we can eliminate. Let's check out the first one. Let's just do it. Y is equal to 2 times 1, and you subtract 1. So this is 2 times 1, which gives you what? That gives you 2, minus 1, that gives you 1. So that works out. Then you're going to do the next one, 2. 2 times 2 minus 1. 2 times 2 is 4, minus 1 gives you 3. That works. You got 2 times 6 minus 1. 2 times 6 is 12, minus 1 is going to give you 11. That works. 2 times 9 minus 1. 2 times 9 is 18. 18 minus 1 gives you 17. So A is the correct answer there. All of them work. Okay? All right, pause if you need to. Okay? Tonight's homework, back page. Tonight you're going to do this for homework. This was Monday. This is Tuesday. This is Wednesday. And this is Thursday. Okay, so if you didn't write that down, you can write that down. All right? Okay. So now I need you to take out your composition notebook and open it up to page 13. 13. Yesterday we talked about the real number system. We put this graphic organizer in there. Okay, put the graphic organizer in there, and we should have already done this side. So I'm going to do this side here with you. All right, so we're going to take this list of numbers and put it into the right category, okay? So here we have 4 over 5. 4 over 5 is not a whole number, it's not an integer, but it is rational. It's not irrational. A number can't be both rational and irrational, but all numbers are real numbers, okay? Negative 18 is not a whole number, but it is an integer. It's also rational, can't be irrational, and every number is a real number. Okay? 0 is a whole number. It is. It is an integer also. It is rational, can't be irrational, and all numbers are real numbers. The square root of 5 is a non-perfect square root, so it's going to be irrational and real. That's all it can be. It's not going to be anything else. A negative fraction is not a whole number, it's not an integer, but it is a rational number because it can be written as a fraction. It is a fraction. It can't be irrational, but all numbers are real numbers. This decimals can't be whole numbers or integers, but they can be rational. Okay, and it stops. It's a terminating decimal, so it's definitely rational, and all numbers are real numbers. 5 is a whole number. It is also an integer. It is also a rational number, and all numbers are real numbers. Pi, remember pi is irrational because it's a decimal that continues on and on without a pattern. It never stops. Okay, we don't know what number is coming next. And all numbers are real numbers. This is a repeated decimal. Repeated decimals are not whole numbers, they're not integers, but they are rational. They are rational. I know what number is coming next, and I could write this as a fraction if I needed to. Okay? So it is also a real number. It cannot be irrational. Number can't be both rational and irrational. This last number has the dots at the end, which means we don't know what number is coming next. It's a non-terminating decimal. So that goes here with irrational numbers. Dot, 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 dot. We don't know what number is coming next. All right, so down here, I want you to pause the video and see if you can fill this out. You're going to check it off if it's a whole number, an integer, rational, irrational, or a real number. Pause it now. All right. So let's see. Real numbers. All numbers are real numbers, so you should have a check going all the way down here. Okay? Now let's look at if it's a whole number. If this is a whole number, it's not, but it is an integer. It is irrational because you can write it as a fraction. So that means it is not. Oh, my screen. Hold on 1 minute. I don't know why my screen is going. Sorry, y'all. All right. It cannot be irrational. Okay. Here, a fraction is not a whole number. It's not an integer, but it is rational. A number can't be both rational and irrational. Non-perfect root is irrational. That's all it can be, is real and irrational. 5 is a whole number, it's an integer, and it's a rational number. All numbers are real numbers. This decimal is not a whole, it's not an integer, but it is a rational number. A number can't be both rational and irrational. True or false down here at the bottom. All integers, every single integer is a rational number. That is true. Okay? If a number is rational, then it must also be a whole number. That's false. Okay? Not all rational numbers are whole numbers. Some irrational numbers are integers. No irrational number is an integer. Okay? D, all irrational numbers are real. Yes, every number is a real number. No whole numbers are integers. All whole numbers are integers. That's false. Okay, every single whole number is also an integer. All right, so you should be finished. If you didn't finish this other side from yesterday, pause the video and finish that. All right, now that you're done, you can go ahead, close this up. Okay, and now I want to remind you, friendly reminder, that this should be by Tuesday. The note cards, you should already start making the note cards. Remember, there's a front and a back, so please don't wait to the last minute to get that done. Do not wait to the last minute to get that. Oh, actually, I don't know why I closed the notebook, y'all. I'm so sorry. Please open the notebook back up. Lord help me. All right, so the next page that we're doing is page 14. This is Q1 at the top, and we are doing page 14. Okay? The name of this page, we're going to do some vocabulary words for expressions and equations. So we got vocab for expressions and equations. These are just some words that you need to know as we're talking about equations, expressions and equations, okay? So there's a little foldable that I gave you on yesterday. Foldable, it looks like this. Make sure you take out a pair of scissors, okay, and a glue stick. This is the foldable. I am going to take my scissors and I'm going to cut the bottom off. Cut this bottom off so that this foldable can fit on my, it probably would have fit anyway. All right, so now there's a line down the center. So I'm going to fold this over, but I'm going to make sure that this line is on top of the line that's directly under it. Okay, so I need to fold it. On that line there. This is the part that you're not going to use. You're going to put glue on this part. Okay? All right, so I can actually cut off if I wanted to. I don't have to, but I could, if I wanted to, I could just cut off this extra part right here. Okay? All right, so now I'm going to cut these little slits right here so that I can fold and open them. So cut all the way, see that, all the way to the line. Okay, make sure that you're not cutting this part. You're just cutting this. Might not be perfect, because I did try to copy this on the copy machine the right way, but you know, did the best I could with that one. All right, so now we're going to take glue and we're going to put glue on this side right here. You put glue on the edges, okay? And we're going to put it right here on this page. And instead of having to write all those definitions out, the definitions are already there. Yay! Okay, so this is going to be just a quick review because most of these you've already heard me say and you've already confirmed that you know these for the most part. So let's look at coefficient. Remember what a coefficient is. A coefficient is a number used to multiply the variable in an algebraic expression. Basically, a coefficient is the number that's in front of a variable. It's just the numbers in front of a variable. Why they say multiply? Because it's automatically multiplication between the variable and the number. Okay, so that's why they said multiply. Because this is multiplication between a variable and the coefficient or the number. Constant. Okay, I didn't cut this enough, did I? A constant is a fixed value. It's the number that has no variable attached to it. Okay, they said a fixed value because there's no variable in that's attached to it. So it's a number or a variable of its own expression in the equation. So really, technically, a constant it has no variable attached to it. I don't know why they said that, but it's no variable attached to that. Okay. This one is an equation. Equation has expressions that are made equal to each other. This is an expression on this side. This is an expression on this side. Mathematical sentence that values of two expressions that are equal to each other. Same thing. An expression over here and an expression over here. Two expressions that are made equal to each other. Then what's an expression? An expression is a combination of numbers, variables, and mathematical symbols. Okay, so there are two types of expressions. Algebraic expression and a numerical expression. Algebraic expression has variables, numbers, and operations. A numerical expression just has numbers and operations. Okay? Term. A single term. Okay? It can be a number. It can be a variable. It can be a number and a variable together. Okay? But their terms are separated by addition and subtraction signs. A variable. Variable is an unknown. It's a letter or a symbol that represents a number that we don't know. Okay, so those are your definitions there. Okay, so please make sure you study your definitions. All right, page 15. Pause if you need to. Okay, this is Q1 at the top. Slide this down a little bit. And this is going to be page 15. Page 15 is going to be expressions. Okay, and I need to put solving expressions, really. Okay, so again, there are two types of expressions. There are two types of expressions. Okay, two. One is a numerical expression. Pause if you need to, okay? A numerical expression is a combination. It's a combination of numbers and operations. What do I mean by operations? Addition, subtraction, multiplication, division. Okay, those are operations. Sometimes you'll see some symbols like the parentheses, the fraction bar. You'll see symbols, okay? All right. The second type of expression is an algebraic expression. Algebraic expressions are a combination of numbers, okay, operations. See what they have. They both have in common. They both have these two things in common: numbers and operations. But an algebraic expression has variables. That's the difference between the two. Numerical expressions do not have variables. Algebraic expressions, this is what the difference is. Algebraic expressions have variables. Okay? Pause for the cause if you need to. All right? The big question is, how do you solve expressions? That's the huge $1,000,000 question. Is how do you solve expressions? Okay, so these are your steps. Okay, all right. So in order to solve, you're going to use order of operations. This is how you solve it. You use your order of operations. All right. Please don't say PEMDAS, because remember, that's another acronym to help you remember the steps. Okay. All right. So remember with PEMDAS, they said parentheses. So the first step is do all operations within parentheses. Do all operations within parentheses. Okay. The second step, after you do all the operations that are within the parentheses, your second step is going to be to what? What do you think your second step is going to be? Okay, so PEMDAS, please excuse, you're going to evaluate your exponents. Oops. I was just going to say exponents. Let's put solve. Okay, see how you can use your PEMDAS or use those acronyms to figure out what the real steps are. So you got your exponents. Then you're going to, says, please excuse my dear Aunt Sally. You're going to multiply or divide from left to right. Whichever one comes first in the problem, that's the one you do. So multiply or divide, whichever one comes first, in order from left to right. Okay? Multiply, divide in order from left to right. Okay, number 4, the last step for your order of operations is to add or subtract in order from left to right. Whichever one comes first. Add or subtract in order from left to right. Okay? Alrighty then. So now let's do an example. Please pause if you need to pause, okay? Rewind if you need to rewind. So we got an example. Okay, number 1. We have for a numerical expression, let's do a numerical first and then algebraic. Let's do 3 plus 5 in parentheses, 8 plus 2. Okay, and then let's divide by 2. All right, so let's do the top first. Let's do what's in the parentheses. So 8 plus 2 is 10. So we have 3 plus 5, got 10 there, divided by 2. Okay, so now you're going to multiply here. That gives you 50. Then you're going to add 3. So this gives you 53 on the top, divided by 2. Okay, so look, we got 53 divided by 2, and that's 26.5. Okay, let's do an algebraic one. Okay, an algebraic expression. Let's do 8, 2n plus 1, and let's do minus 4. So let's do what's in the parentheses first. We can't. So now we're going to use distributive property. This gives me 16n plus 8 minus 4. So now we're going to combine these terms together. I'm going to subtract, and that gives you 4, positive 4. So that's 16n. You cannot simplify this any further. So that's going to be your answer there. So we did an example for a numerical expression, which has a combination of numbers and operations. And this is an algebraic expression. So this is numerical expression. And you solve them the same way by using your order of operations. And this is an algebraic expression. Pause if you need to pause, okay? Pause the video if you need to pause the video. All right? So now we're going to work on the guided practice problems, okay? We're going to work on the guided practice problems. You can close this up. And let's work on the guided practice problems. All right? We're going to do some, and then you're going to do some on your own, okay? All right. If you write on, let's see. Let me see if this is enough space to write on this, okay? It may be. All right. If it's enough space for you, go ahead and write, but make sure that you show your work, okay? So your x is 1 and your y is 2. So this is going to be y divided by 2 plus x is 1. So order of operations, y is 2. So order of operations, let's do this first. 2 divided by 2 is 1. And then 1 plus 1 is 2. Okay? All right, so let's do this one. A is 10 minus 5 minus B is 4. Order of operations tells us to do this first, which gives us 5. And minus 4, this gives us 1. Okay? Let's do this one. P to the second. P is 5. So that's 5 to the second plus M is 1. So we got 5 times 5 is 25 plus 1 is 26. All right? Pause if you need to, okay? Pause if you need to. We got Y, which is 3. So this is 3 plus 9 minus X, which is 1. So we do this first. 9, 10, 11, 12 minus 1, which is 11. Okay? All right, so I'm not going to do all of these for you. I want you to work on all of this. Make sure you get all of this done. Turn over on the back side. Actually, what I want you to do is, let's do the ones that are circled. I'm going to circle the ones I want you to do. Because I want you to try number 7. I want you to try number 9, number 11, number 12, number 13. On the back, I want you to try 17. Oh, 15 is good. 15, 17, 20, 22. Let's do 24, 26. Let's see, how many problems is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so that's 11 problems there. So do the ones that are circled. Take a picture and submit this on the Canvas page. All right, so I'm going to show you how to get there. All right. Okay. Let me go out of this. All right, so I want you to go to my dashboard. I want you to go to my page. Look at this. Okay. Slide this down. This is week 2. This is where we are. Okay. This is what's due tomorrow. Okay. This is what's due today. You're going to do this today. Okay. Tuesday. All right. The video that I'm recording right now, I'm going to put here for you to watch. Okay. You can either click here to submit the assignment or at the top of the page. It's both the same link. Okay. It's the same link. I'm going to put this in student view so I can see what you see. So I can either click up at the top or I go to Tuesday and click right here. All right. Okay. All right. So now this is how you're going to upload or to submit today. You're going to go to your camera. I'm going to search for my camera. I pull my camera up, take a picture of the front side. Please make sure I can see it real good. Take a picture, okay? Take a picture of the back side. Take a picture of the back side. Make sure I get everything. Make sure my fingers aren't covering my work. Okay, so now I can close it up. Now I am going to go here and add media. Okay, and I'm going to go to my pictures, camera roll. Pictures are on the bottom. Okay, put them in the order that I want me to see them. Do the first page first, make it bigger. Okay, make sure I can see it. And then upload here to get my other picture. Okay, and I probably need to put that on the second page so I can make it bigger as well so I can see it. Oops. Okay, make sure I can see it, make it as big as you can, and then submit right here. Okay, then submit right there. Go ahead. If you're finished early, go ahead and work on your homework, okay? If you finished early, just work on your homework. Let me delete this stuff. So this doesn't affect what you see. All right. If you finish, like I said, if you finish early, go ahead and delete. Go ahead and work on your homework, okay? Make sure everything is completed. Guys, please be nice to the sub and have a wonderful and blessed day. Love you. See you tomorrow.